All right, good morning. Good morning, class. Hope you all are having a fantastic day. Hopefully, it's not too snowy where you are, but I guarantee it is. Um, yeah, happy snow day. It looks like, Granite District's got a snow day. We've got a snow day. Salt Lake District even has a snow day. Apparently, Nebo District and Davis are doing late starts, so be grateful you're here. Okay, so couple things today. All right, there is an assignment today. It is a 6.9 practice problems, right? In order to successfully do those, though, you will have to look through the lesson summary today. Okay, and that's kind of what I'm going to walk y'all through is what we need to know how to do in order to successfully navigate these practice problems. Okay, so our lesson today is lesson 9, looking for associations in data, which again is what we've been doing, except we've been looking for associations in numerical data. So what this lesson's about is looking for associations in categorical data. And of course, with categorical data, we can't use scatter plots. So we'll be using segmented bar graphs, two-way tables, and relative frequency tables, which two-way tables and relative frequency are quite similar. Okay, we use the same numbers. So let's check this out. Oh, look at that. Bar associations, bar graph. Look at that. What do you notice? What do you wonder? I see that people who don't play sports, right? No sports, according to this, watch more TV than people who play sports, right? That's what we're seeing. Okay, not much TV. Still, people who don't play sports don't watch much TV. There's not really much of an association there, but we can see that there is an association between watching TV and playing sports, right? Okay, so bar graphs. We've seen those. Okay, this is an example of a two-way table, all right? Now in a two-way table, we're comparing two variables that are categorical. I know yesterday I used the example of, on that video, I was asking skiers and snowboarders how many hours they slept. Okay, skiers and snowboarders is a piece of categorical data. They're two categories, right? Or it's what you call a categorical variable. All right, now how many hours you sleep, that is quantitative. That is numerical, a numerical variable. All right, so here we're comparing two categorical variables, right? Whether or not you have a cell phone, and actually age is going to be, well, usually age would be numerical, but as you can see, we fit it into three categories, right? 10 to 12, 13 to 15, 16 to 18, okay? So on a two-way table, which is what this is, you've got your variables kind of on the sides of this two-way table. You can see the totals on the sides as well. All right, so what this is telling me right now is the total of 10 to 12-year-olds that were surveyed is 60. Out of that 60, 35 do not have a cell phone and 25 do. See what I mean? Okay, same thing with 13 to 15-year-olds. Okay, the total of people surveyed was 50. 10 of those 50 did not have a cell phone, 40 have a cell phone. And it also works the other way. If you're looking at the columns, right, do not have a cell phone, all the people that do not have a cell phone was 55. That was the total number of people who don't have a cell phone. Okay, 10 of those were 16 to 18. 10 of those were 13 to 15, but 35, the vast majority of those people who don't have cell phones in this group were 10 to 12 years old. Okay, so we can get a lot of information from a two-way table. All right, but even still, if I was to look at, okay, what's the majority? Do the majority of people have cell phones later in life or earlier in life? For that kind of information, we can still kind of tell on this. For example, like I can tell you, oh, 10 to 12 years old, most people don't have a cell phone at 10 to 12 years old, according to this data. And most people, 16 to 18 years old, do have a cell phone. Okay? I can also tell you that the majority of people who don't have a cell phone out of this data were 10 to 12 years old. Okay? So we can answer a lot of questions here. But when we start looking for associations, those are a few of them. a relative frequency table is going to be more helpful. Now let's go check one of those out. Okay, let's go to this lesson summary. So a relative frequency table is a lot like a two-way table. It's set up the exact same way. We can see here we've got a relative frequency table. Now, relative frequency is really just another word for the percentages, right? So out here we're comparing the two variables, right? If you meditate or if you do not meditate. And the variable of if you are calm or agitated, right? We're comparing those. Now, in order to understand a relative frequency table, we've got to look at the two-way table here. Okay, so we've got a two-way table comparing the same information. All right, did we meditate? Did we not meditate? Are we calm or are we agitated? Now, again, you can see here, right, out of the people who are calm, most of them meditated, like the vast majority. So we can kind of see an association there. All right, the people who were agitated, well, still, most of them meditated. Okay, so it's not quite clear if meditation actually causes us to be calm versus agitated, right? We can say that out of 68 people who meditated, most of them were calm. That's kind of a pointer to meditation being able to calm us, right? So when we're creating a relative frequency table from a two-way table, all right, we want to pay attention to our totals, okay? So if they were to have us fill out this relative frequency table, let's say they did that. Let's say we had no information in here, just have a blank percentage. I love the sound of snowblowers in the morning. It's great. So check this out. You see how down here, well, let me erase the rest of this stuff. You see how down here we've got 100% at the bottom of the columns? Those are our column totals. If we had 100% here, we'd be using the row totals, all right? Now, row totals being the totals that are at the end of the row. Our column totals are the totals at the bottom of the columns, all right? So for this relative frequency table, we're using the column totals, all right? So check that out. So what this is asking is 68 is 100%. For the relative frequency table, they want to know the percentage of people who meditated that are calm. All right, now to find the percentage, remember we divide the part by the whole. So I'm going to do that on my phone, okay? Just for the sake of being quick here. All right, so what I want to do is I want to figure out what 45 divided by 68 is. Okay, what's that percentage? 45 divided by 68 is 0.66, okay, or 66%, okay? So the percentage of those who meditated who are calm is 66%. Okay, let's double check our answer there. Oh, look at that. We're right. Okay, so from there we can kind of just use subtracting, right? If 66% of people are agitated, that would mean 34% are not. But let's just double check using math because it's fun, right? So 23 divided by 68, what do we get from that? Come on, phone. 23 divided by 68 gets us 0.38. All right, so that's 0.338, which rounds to 0.34 or 34%. Ta-da! Okay, so again, we can do this for the percentage of people who did not meditate as well, or for the totals of people who did not meditate. So out of those who did not meditate, what percentage were calm? All right, let's look up here again. Okay, out of those who did not meditate, we're looking at this column right here. Okay, out of those who did not meditate, out of the 29, 8 of them were calm. Now, what percentage is that? Well, that's where we do our trick, right? So 8 divided by 29, 0.275 or 28%. Okay, 28%. Now, that should be the same down here. Yes, it is. I love this. I love being right. It's so great, especially when you're wearing a big, fuzzy, warm hat. Okay, same thing here, right? 21 divided by 29 gets us 0.724, which is 72%. Let's see if we're right. 72%. Can't get enough of it. Okay, so that is a relative frequency table and how we make one. Now, the only way this would be different is if instead of the row totals being there, right, let's just pretend they're not there for a second. I have to get a bigger pen for this, okay? Let's pretend the row totals weren't there and we instead had, or the column totals weren't there. Let's pretend instead that we have row totals, okay? So we've got total, that doesn't look like a T at all. Totals, and we've got our row totals at 100%. Now this changes our relative frequency a bit, because instead of looking like out of all the people who did not meditate, what percentage is calm? Now we're looking at out of all the people who are calm, what percentage of those people did not meditate, okay? Now this allows us to kind of get some better ideas on the associations here. Okay, we can do that the same way. Let me just erase all this junk. Erase all the junk. Right, so how that would change is instead of doing 45 divided by 68, the column total, because we have row totals here, we're going to use those row totals here as well. Okay, so for example, what's 45 divided by 53? 45 divided by 53. Oh, it's 0.849. So we've got 0.849, which is really just 85%. I rounded, so 0.849 rounds to 0.85, hence 85%. So we can put that there. All right, and if you're in a rush with your relative frequency table, you can simply add here, right? What plus 85 equals 100, or what is 100 minus 85? Well, that's 20. Ooh, no, sorry, 15%. It's the same answer you'll get if you were to do 8 divided by 53. Which is, let's see, 8 divided by 53. Look at this. 0.15. 15%. Amazing. Okay, let's find these bottom ones. And if you want to pause it and see if you can find the bottom relative frequencies first, the row totals, that's fine. Be a great practice for those practice problems, because you will have to create a relative frequency table in the practice problems. And this is, again, how you do it. Use this video. It's great. Okay, so here we're trying to use the row totals, so 23 divided by 44. Let me erase all this junk. We don't need that anymore. All right, so 23 divided by 44. Look at that. We get 0.52, okay, or 52%. So if we have 52% here, what does that mean we have on the other side? Well, probably 48%. And if you were to do 21 divided by 44, you'd probably get something like 0.48. Okay, so that is how we do relative frequency tables by row totals, all right? And this is how you do relative frequency tables by column totals. You can see the column totals there, all right? So you know whether or not to use column totals or row totals to make your frequency tables by looking at the setup for the relative frequency table. Again, if they have 100% at the bottoms of the columns, you're using those column totals here. Okay. However, if they have row totals at the end, so the 100% is at the ends of the rows, then you're going to use the row totals, all right? Or these right here. Okay, so that's kind of a crash course in relative frequency tables. All right, pretty fantastic, right? And I believe, let's take a look at that homework real quick. Just want to see. Okay, so, yep, you've got to know if, okay, so this is great, right? So here, question number 1, a scientist wants to know if the color of water affects, what time are we at? How long have I been talking for? I just got to double check. What are we at, recording wise? 15 minutes. It's not bad. Okay, so in the lesson 9 practice problems, the first one, which is a question I want y'all to be able to do. Actually, same with the second one. Yeah, second one's going to be good as well. Number 4, y'all's can do. Okay, so for number 1, a scientist wants to know if the color of water affects how much animals drink. Okay, we could assume what? Do you think the color of water affects how much animals will drink? Let's find out. Okay, so the average amount of water each animal drinks was recorded in milliliters for a week and then graphed. Okay, just a heads up, we will be going over this tomorrow. Okay, so I'll give y'all's a, tell you if you're right or wrong tomorrow. Okay, is there evidence to suggest an association between watercolor and animal? Well, if you're looking at the two-way table, okay, we can see that cats, out of all the cats, 210 drank blue water and 200 drank green water. Okay, it's not the biggest difference in the world. It's pretty close. Okay, and for dogs, 1,200 drank blue water and 1,100 drank green water. Okay, so it's pretty even there as well. A few more are drinking the blue water, but not many more. Okay, so this is kind of what we'd call a negligible difference, right? The difference between, so 210, so 10 out of 410, let's see, 10 divided by 410 is 0.024. So that's about 2% more cats are drinking blue water as opposed to green water. 2% is not a big difference. That's what you'd call negligible. Okay? And if we look at our graph, we're kind of seeing the same thing, right? We can't really see a difference in the graph. As far as green water goes, dogs are pretty much on the same page. They don't really care. Okay? Cats, also at the same level. Okay? They don't really care. Now, why don't animals care what color their water is? Something to consider would be, do animals even see color? Right? You tell me. Google it real quick. I bet y'all know this actually. Okay? So that's kind of how question 1 is going. So you don't have to make a relative frequency table here. You can get all your answers from our segmented bar graph or from our two-way table. Okay? We can get that information there. Now here, a farmer brings up his produce to the farmer's market and records whether people buy lettuce, apples, both, or something else. All right? So it actually tells us to make a table that shows the relative frequencies for each row. Okay, that's really important. That means we're going to use the row totals here, which in this case, the row totals are whatever 14 plus 58 is, right? So we've got 72. All right, and then 29 plus 8, that's 37. Okay, so those are our row totals that you need to use to get the percentages for the relative frequency table. And I think on the practice problems, I actually have this for you, right? Like I have the layout of the table. So we'll just say lettuce and no lettuce. Let us have a snow day today, huh? Okay. And then we've got apples and no apples. Now remember again, we're using the row totals like it said here. All right, so that means our row totals are going to be the 100%. And we've got to use that to figure out the percentage of people who bought lettuce and also bought apples. All right, so out of all the people who bought lettuce, what percentage bought apples? Let's figure that out real quick. So we've got 14 and 72. Okay, so 14, keep unlocking this. 14 divided by 72 gets us, oh wow, 0.194. So 0.194, that is pretty much just 19%. Okay, you guys kind of understand this a little bit? All right, so I'm taking, in order to get that percentage, I'm taking the number from the box that I'm filling out here, I'm dividing it by the row total associated with that box, and then I'm getting a decimal, and technically I'm multiplying that decimal by 10, okay, or by 100, sorry. Multiplying that decimal by 100, okay? You do that for the rest of these boxes, you've got the answers, all right? Now, number 3, researchers at a media company want to study new reading habits among different age groups. They tracked print and online subscription data, made a two-way table. This is interesting, right? So what age groups of people get their news from? Internet articles, right? Things that are on the computer. And what age group gets more of their articles from print, like newspapers, magazines, that sort of thing. Okay? And you're kind of seeing the same thing. Well, you're kind of seeing what you'd expect, right? People much older, 45 to 65 years old, the majority of them are getting their news from print, right? Because 165 is a lot bigger than 48. Okay, the younger you are, for example, 18 to 25-year-olds, most of their information comes from internet. Okay, so it has you create a segmented bar graph. All right, which again, if you need to do that, check out the lesson summary. It tells you how to create a segmented bar graph. Okay, using one bar for each row of the table. So that would mean in your segmented bar graph, each bar would be representing the row. So we've got 18 to 25, 26 to 45, and 45 to 65. So, and that's whether they get their news from the internet or from print. Okay? So, with that, actually, sorry, let's make internet and print. So internet and print aren't actually going to be on the axis because we've got our number of people here, right? So if you go up by 10 or 20, right, you want to be able to reach 170 because our largest number is 165, okay? If you made, let's say you made prints, let's make print blue, and let's make internet this highlighter green, okay? So I'll do one of these bars for y'all just to show you what I mean, okay? So let's do 18 to 25 years old, all right? Internet articles are going to, well, we've got 28 for print articles, right? So let's do, well, we've got all the way up to 170, right? Oops. So I'm gonna be very, very broad with this, okay? I'm just gonna estimate kind of where 28 is. All right, so let's say 28's right there, okay? Now, what's 28 plus 151? What's their total? Well, it should be around 150, 170, yeah, 179 would be the total there. So if we fill up the rest of this with internet, we would expect that to reach up to 179, which is above 170, okay? Your bars need to reach the totals, right, for each row, okay? So there you go. That's how we're doing a segmented bar graph for this data, all right? And then it also asks, is there association between age groups and the method they use to read articles, all right? I'm gonna let y'all answer that question because want to see what y'all say. All right. So that's a little intro on the homework. That's a little intro on the lesson. Get that work done. Give it a go. Don't watch this video for too long because I think I've been talking for like 20 minutes now, 25. Goodness gracious. Okay, so hopefully you're piecing together bits from that. All right. Hope y'all have a fantastic day. If you have questions, email me and I'll get back to you as soon as I can. I conveniently have an MRI appointment at 10:30, so I'll be gone at 10 for that, but if I can, I'll get back on after the MRI appointment, answering as many of your emails as I can. Okay, good luck, folks, and make sure you get practice problems for 6.9 done, all right? Thanks. Bye-bye. Oh, stop recording.